Bonjour à tous.
Good afternoon, everybody. We're going to start. Thank you very much for being here with us in such great numbers on a subject which is a very interesting subject, very much in the news at the moment. My name is Philippe Gros. I'm a senior researcher at the Foundation for Strategic Research, focusing on military issues, and particularly in America. We have with us Madame Amaral, Mr. Fischler. Madame Amaral is from Chatham House, Mr. Fischler from Airbus, Mr. Ria from MBDA, Mr. Levy from Naval Group, and Mr. Collot from Thales. I should point out that you have the biographies of the speakers in your program, apart from Mr. Collot, who's replacing Mr. Lancelot. Mr. Collot is the manager of naval strategy at Thales. So we're going to start. We're going to organize this roundtable. I should also say, first of all, that I would encourage you to take a photo of the QR code, or put the code into the Slido webpage, so that you can ask questions. And we'll draw a number of those questions out of the box, and then we won't be able to ask all of them. The roundtable is going to be centered around a series of themes. The theme we are focusing on is artificial intelligence, drone systems, and the future of collaborative warfare. These are concepts that are overlapping but are slightly different. You can have drone systems without artificial intelligence. You can have collaborative warfare without drone systems, etc. So we're going to talk about this. We're going to hear about the expertise of our speakers on these different themes in the form of an open discussion between them. And then we will have some questions and answers from the audience on each of these themes. So the first theme we're going to talk about is the question of what collaborative warfare is, what it represents. So I'll turn now to who would like to start. So I'll be talking more about airborne aspects as a representative from the SCAF when I'm talking about the future airborne warfare system. We're not talking about a fighter aircraft that is going to replace Eurofighters and existing Rafales, but more a system of systems. So you'll have an aircraft, you have drones of different sizes that will cooperate with sensors and effectors, and in the space and on the ground with a marine dimension as well. All of these systems will cooperate and generate a huge quantity of information, which they will share in order to reconfigure themselves and adjust and execute certain parts of a mission, either together or separately. And all of these data that will be transmitted between the aircraft and the drones will be processed. And this is one of the major themes of our theme today, which is artificial intelligence, to be able to assist pilots in their cockpit when they're carrying out a mission in a squadron with unmanned drones. When we talk about future combat systems, a pilot will no longer be a pilot. They will be a mission commander in order to manage all of this information in their cockpit in collaboration with other players, including drones. The use of AI is absolutely primordial and is necessary, in fact, in that context. So those are the basic lines of how we see collaborative warfare at the SCAF, with two main dimensions, which we have to be one step ahead of the enemy in terms of decision making. As we heard this morning, we talked about the acceleration of the tempo of the future conflicts with enemy forces who are already operating in a network, and which will try to anticipate what we are going to be trying to do in our air forces. So we have small windows of opportunity tactical opportunity which we have to take advantage of. And to do that, we need to have two capacities. We have to be able to take decisions quickly and be able to reconfigure very quickly. And so this decision-making, agile decision-making, is an integral part of collaborative warfare. And this has to be assisted by AI because the capacity of the human brain in this cycle will not have the capacity in real time to take all of these decisions and to manage all of these data. So AI will offer solutions that humans will have to validate. We'll talk later on about the ethical dimension in real time and very, very quickly. So this is what we do in our Future Combat Air System, FCAS. I'm going to talk about the problem slightly differently from the point of view of the missile maker. We produce missiles mainly. For us, collaborative warfare has three levels. The first is collaboration between the platforms. There's also work on the collaboration between these platforms, and this is very useful because the systems will be able to benefit from this collaboration. As Bruno said, this collaboration will enable players to develop a tactical situation more completely, to provide more opportunities to engage the adversary rather than if the platforms are working alone. So the platforms will be able to engage more frequently and in better conditions because the possibilities will be more robust. Then you have cooperation between the platforms and the effector that you're going to engage. Then you have a different type of cooperation directly between a platform and an effector that is going to carry out a mission. This is known in the air defense world. We have bottom-up links that will be able to provide information to refresh the situation, to give a precise indication of positions in the interception phase, to be in a favorable position to carry out the final interception. The system which we use frequently in air-to-air or ground-to-air is something we now need to integrate into more tactical strikes when we are striking with missiles and objectives and targets that are on the ground. And we have to have interoperability between the platforms and the effectors to be able to refresh the information for the benefit of the infectors, so that when there is a change in their environment or in the type of the target, this will give them greater tactical flexibility. In all of the combat system, the final layer is the connection between the effectors themselves. If you take a group of effectors which are firing together onto the same target, you have to make sure that they communicate with each other. If, for example, as they move forward, the tactical situation changes, you'll have a new defense system that will push and will have an impact on this group. If you have elements that are connected to the platform which can give them the information, then if the effectors are connected together, then they can take decisions in an intelligent way and adapt their trajectory either to separate or to group together or to resynchronize to have a more effective attack. And to do that, they have to be able to talk to each other and have to be connected. For us, that is what collaborative warfare is. The first one doesn't concern us as manufacturers because our colleagues are in charge of the manufacture of these platforms. The second layers are layers we're more involved in directly. This is a collaboration between platforms and the effectors, and also then communication between the effectors individually.
So in terms of collaborative combat, I think integrating AI systems in military equipment and systems brings really, really huge advantages to militaries and to how we fight wars. I know other people here will be working on these systems and be able to explain this really well. But I find that in being able to provide real-time information sharing, military operations can be coordinated much better, and there will be better communication, better situation awareness of the whole battle space. But I do think that, as we know, AI brings risks, and some of those risks are part of how those systems are developed in terms of biases or there being a lack of data integrity. So this also matters a lot. And my worry in here mainly is that because we're integrating AI across every system and every platform, if there's one flaw or failure in one system, it could have a cascading effect on other systems. So for example, we use AI for data analysis, and then we will use that information for selecting targets. So if something fails on there, it could have a negative impact on another system and on another decision. And we also need to recognize that there will be, impacts on international peace and security more widely. We know that there's a competition for AI leadership at the moment, and that could lead, to a competition for, AI weapons and systems. So I think those are the things that I would say. And also, I think we should highlight that Ukraine is doing really well at integrating these systems and using AI for data collection, analysis. They're automating drone takeoffs and landing. It's giving them huge advantages. So.
Bonjour à tous. Alors,
Good afternoon. I'm going to talk representing Thales, but not only in the naval sphere. In concerning collaborative warfare, the winners will be those who are able to do more than can be done alone. There's a question of gain in terms of speed, to be able to do things more quickly and to be able to process more information. At Thales, we are a key player in this transformation of collaborative warfare in the world of land and sea. We use the four pillars of the digital world: the connectivity, big data, artificial intelligence, and cyber. We have already developed a system, Lexion, which is a combat club. When you talk about combat club, this is collaborative warfare. We're talking about data processing, data storage, and connectivity. These are things that make it possible to share information very quickly with very little latency, information that has already been processed and analyzed, and to be able to process this amount of information which isn't possible at the moment. When talking about our radar, this is 10 terabits per second that is being processed, and obviously, when for this data, this represents tremendous potential when we exploit it in cooperation with other systems. As has already been said, this concerns different layers. We have the system layer, with the preparation of monitoring and the feedback from a mission in the level of the drones. We'll come back to the drones later, but the drones are inherent to collaborative warfare because they can extend our capacity to see and to take action in a number of conditions. And in terms of the sensors themselves, because the drone is a vector, but it also will put in place a sensor or an effector which will need to process the information and share the raw information, and this will lead to making a decision more quickly for the operator, who will then make the final decision based on all the information that is presented to them. On all of these different levels, we are working at those different levels at the moment to have a collaborative warfare system, and we need to have a certain level of confidence. We'll come back to that later, I expect. Good afternoon. I'm the last speaker, and so I'll be a little bit redundant, but I think we're all very well aligned, I think. Concerning naval forces, the challenge here concerns the current geostrategic context with the extension of conflicts on all of the seas and oceans in the world, which forces navies to rethink the format of their forces to be able to ensure that they can have a permanent presence in the sea. Drones and unmanned systems are one of the solutions because a drone makes it possible to see further on the surface and in the air and underwater. That's also very important, and in permissive and unpermissive environments, because it makes it possible not to expose high-value assets or personnel. So in concrete terms, if we look at the US Navy, which is the first Navy to have announced the changes in its forces by 2030, they've announced they will complete their systems with about 100 drones and unmanned systems to meet these future challenges and in conflicts. From a technical point of view, in the naval sphere, there's one important challenge, which is to have communication between the drones, unmanned systems, and the armed forces. We have to be able to ensure these means are available at sea, regardless of the sea conditions. This means we have to have automated systems which will make it possible to implement them and to recover them, and also to be able to provide a handover between several vessels when a drone is put into action, so that it's not left organically connected to any one vessel. And another important challenge is the functional integration, because these drones will recover a lot of information and will also have a very precise mission, which will be increasingly complex. And so the integration of these drones into combat systems is a primordial challenge for navies to be able to integrate all of these data into the tactical situation, which will be managed by a combat management system. And then tomorrow, to be able to work in a more collaborative way, we're talking about man-machine teaming. There we have naval collaborative watch systems. So we have this collaborative warfare, including drones and aircraft, so they will be able to provide this raw data. And then we'll have the collaborative engagement, whether it's for self-defense or for deep strikes, and also for engagement of weapons from these autonomous systems. Another challenge is something we've already mentioned, is the connectivity of naval forces. There's a lot of challenges around connectivity. These systems have to be have the maximum amount of communication systems. There's a lot of challenges underwater, on the surface and in the air. We are meeting the needs. On underwater, there is a real technical challenge, and there's also another issue, is big data. We have to be capable of collecting, storing, and exploiting these data. And clearly, AI will provide real solutions to favor and facilitate use by the operators, so that the operators have full control of these systems. This is a key challenge. We'll talk about this later. You have to make sure we have these systems remain fully controllable by humans. And finally, I would like to say that if we're thinking about the next decade, certainly it will not be anything like the decade we've just seen, because the technological cycles have accelerated hugely. What we were doing previously was because we had cycles of 3 years. Today, the technological cycles are lasting 6 months. We have to be hugely responsive and reactive, and there are huge challenges, because we have to be able to match the technology with a particular doctrine and technique. This will move us on to the next theme. Thank you, Mr. Levy. I have a question which you've already mentioned, in fact, in the second part of what you said. This is one of the two questions I had, which is in the underwater sphere, which mechanically will use some of the, we use a lot of the unmanned systems, more than on the surface. Could we envisage collaborative warfare in the same way you've seen it on the surface and in the air? Well, yes, absolutely, yes. This is a very big challenge. We've been working on this for many years at Thales. It requires a lot of man-machine teaming and multi-agent working. We will be working with sensors and manned platforms such as submarines, and we'll have unmanned systems or drones, which are less automated. When they say an unmanned system, I didn't distinguish between the two. In the naval group vision, you distinguish between a drone, which is a single mission system, which is pre-programmed or remotely controlled with limited autonomy, compared to an unmanned system, which is designed to be a multi-mission system with more autonomy, and which is capable putting in deploying tactical reasoning according to a doctrine. When you envisage that you're arming an unmanned system, you have to have a framework for the use, and this framework is the doctrine. And this is the operator and supervisor that does this. When you're underwater, the problem is that you no longer have any communication in the strict sense, and so you have to rethink how we see autonomy. We have to put in place mesh networks. We can use acoustic communication over short distances, so we can have communication nodes. Thales is providing a lot of solutions for us at Naval Group. We have put in place docking stations underwater, which are ways of making sure that the drones can regenerate and unload their data, and then also come to these docking points to communicate, because we could envisage that these docking stations could be connected to the land if we're not too far from the coast. I'm talking about an environment where this is possible. And then you have the system itself, which will no longer reason in the same way. If we're no longer limited to pre-programming, we won't be able to have multi-agent or collaborative warfare. So we have to think about having distributed autonomy, where there you will need to have AI in a clearly defined framework, so that the way we manage these unmanned systems is no longer the same as when you have a pre-programmed system. In other words, you define an objective for the unmanned system. This unmanned system dives, it no longer can communicate, it is in an environment, and then it will deploy its mission to achieve its objectives in the framework of a mission which will not be able to escape from. That is a doctrine. So it has an autonomy which will enable it to manage the different sensors and probes. It will give it information about its environment. It will pursue the objective it's been set and has to be capable of saying, I need to go back up to the surface because I need to get more information from my operator, or I need to communicate, or I need to get other information from other assets around me. So it is this autonomy that we're aiming to develop, and we won't be able to do that if we only use Petri networks. And that's why AI and everything it can bring us will enable us to achieve this technological leap, which is what we want to do. Yes, it's important to talk about this in relation to drones and munitions. It's true that drones, by nature, are collaborative. We have a drone that manages a mission by itself in some contexts, but it always corresponds to a mission for which it has been prepared and programmed, and where the objective has been defined. Then it will collaborate with others to a certain extent. There's a trade-off between the communication capacity and the autonomy. At least the more communication you have, the less autonomy you have, and vice versa. And when I say autonomy, I mean intelligence. And then it has to be able to feed back from its mission and process the data. Then when you come back to collaboration between drones, then you have to distinguish between drones which will still be able to communicate, where you can have an orchestration. In other words, the drone will have a mission to achieve within a certain box. If there's an unforeseen event, it has to be able to have the capacity to react and to provide information to obtain the decision. We don't want to be out of a context where the operator is in the loop. We want to stay in that situation. The man has to be in the loop, or a man on the loop. We always have to make sure there's an operator, a human operator, that is able to guarantee the behavior of the drone, provided it can see the drone, which is not always the case. So we have to make sure we have a level of confidence about the drone's behavior that is sufficient. Otherwise, the mission has to be cancelled. Then we have the question of the elevator. The less communication you have, the case of the sensor rather. The drone has to be able to process the information from the sensor. If it's a sonar, for example, the drone has to be able to classify and analyze the data and identify it. For example, saying, I have an object, I'm not certain, I'm going to stop and go back to my zone until I get precise information about what it is. With a higher level of confidence. Here, this again, we're coming back to this idea of confidence. We won't let a drone carry out a mission at a high level where there has a major impact unless we have sufficient confidence in how it is going to behave. So this raises a lot of challenges because communication is limited, and we have to make progress on the development of embedded AI. We're talking about decision-making autonomy or cognitive autonomy, which goes even further. In a way, we have distributed autonomy thanks to the reconfiguration capacities, and the level of confidence depends on our capacity to develop these systems in collaboration with the tools. So very far upstream in the system to make sure we have confidence in how the situation will be managed. We're not going to suddenly have an unexpected type of behavior. So we have tools that are being developed associated with test and validation tools to make sure that the final result will be sufficiently reliable. I'm really from the nautical field. We developed nautical tools previously. We used an automatic system where we launched tens of thousands of simulations with different possible contexts, because otherwise you won't be able to test all of the different capacities. The same thing for these drones. You have tools that enable you to develop AI in a reliable way. This is what we call the array system. In other words, true AI, authentic AI, which is developed in accordance with the processes, which gives a result which remains within what we are expecting, which is understandable and which the operator can control. Thank you very much. I have a question, Mr. Fischler and Mr. Hier, about classification we've seen up to now of the munitions and of the drones, etc. Does it remain relevant? In other words, when you give a munition the capacity to manage itself all autonomously in the terminal phase of its engagement, and we can see that with the information from the war in Ukraine, there's a multiplication of these munition drones with these kamikaze drones as well. With these munitions drones carrying weapons, don't we need to redefine what all of these systems are on a conceptual level and the scope or perimeter of these systems? I'm not sure we need to redefine it. The important thing for me is to the end purpose of the mission that the drone is carrying out. If the end purpose is kinetic, it fulfills a military objective, it remains a munition. However, if we have effectors that are asked to carry out a much more complex mission, to provide information or to provide support or to provide an escort or something like this, then the autonomy has to be greater because we're asking it to respond to a very complex situation. So we're not talking about the same kind of thing at all. And so if something has a military kinetic impact, this remains a munition, and so it has to be managed in that way. We'll talk about this when we talk about the level of confidence. Obviously, when you're using a weapon, it's obvious to everybody that the space-time framework has to be clearly delimited, and the human operator has to be able to change the objective if necessary. I think everybody can agree on that. It becomes more vague when you're asking a system to carry out more complex missions, including analysis and escorting and support. The important thing is that the operators have to have confidence in their tools. And to do that, the tools and their behaviors have to be predictable. They have to be difficult for the enemy to predict, but the operators have to be able to know what the system is going to do. Otherwise, they will lose control of the overall coherence of the response. And they will not be able to guarantee this if they have effectors that they're not able to anticipate in their action. And so the work we have to do raises a question of repeatability. And in other words, the systems we have to make sure the systems behave in the same way when they are presented with the same situation. We have to carry out tests and of a certain level of robustness. Otherwise, the operators won't use these tools. If they're not capable of anticipating the action of these systems in advance, they're just going to control them in a reactive way, and they won't be able to anticipate how this system is going to behave, and that is completely to be ruled out. And concerning the drones also, I'd like to add something else. The system, the way drones are used, it changes the way we use weapons. We have these platforms which are not humanized and which can get closer to the enemy because they're not so, they don't have the same value as a human deployed system. So to engage the enemy, they can use missions with a smaller scale. So this means we have a new type of use for the drones, because the platforms can get closer to the enemy. And this means we can take the decisions and we also have a gain in terms of permanence, because in every environment, a drone can remain permanent in land or on sea, much more than a human which is using robots, which can provide a certain level of permanence in some cases.
If I could just add a little bit to that, I would say, Loic, that there is segmentation because the sensors and all of the other things, and there's also segmentation because of the complexity of the different systems. And I would echo what Cyril has just been saying about naval group. There are certain drones which are single mission. They're either there to scramble or to identify a target. And there are more complex drones which on board or embedded, they will have a payload which in terms of cost must not be lost. So there are different categories of drone, from the smallest ones for single missions, which are very efficient, which could be thrown overboard at the last phase of a mission, but to all these drones which are much more complex, which must be protected because of their cost and all of the equipment that they have. And we really want those drones to come back to the base. And this combination of the different registers between missiles and drones, we see this in terms of the FCAS. At Airbus, we work together because there are some common denominators, all of these swarms and other things and different mission panels. For remote carriers, we've got these support drones which go alongside an aircraft. The remote carrier is which is very complex, which can have a scrambler, telecom satellites, radars, all the rest of it. And they will have their landing gear. They will be able to carry out a mission, come back. These are the most complex types of systems, with a whole range of drones ranging from the most simple one, which weigh about 100 kilos. We're not even reaching the ton mark there. And there are the more specific ones. And we can combine those registers. You can imagine scenarios which we are working on. They're kind of like Russian dolls. There's a big drone which is carrying smaller drones, which are carrying the weapon. So these different drones will have different levels of autonomy linked to their job and the sensitivity of the mission in question. Madam Amaral, if you'd like to chime in.
You see, we're going to discuss afterward about even more artificial intelligence issues and trust, etc. Regarding specifically regarding, I would say, drone systems. From your perspective, do you think issues has evolved over the last period? Things evolved to revolve various issues, raise up since 20 years about that, or how do you see it?
So it is, and what I've looked at is at how we've used drones, let's say in the last 20 years. So I've looked at context and how we've started using them outside contexts of war, of formal war. And I looked at the issues that we found on there, which a lot had to do with the fact that, drones are great with precision, but if the intelligence is not great, there are still many civilian casualties. There were issues related to interfering with sovereignty. So there were more of the political and geopolitical difficulties with drones. And what I see now is that because we're seeing them in a conflict between two states, those issues, in a way, they go away. They're not the same because there is more clarity on what the war is for and who is fighting who. So I find that drones are really, they really bring great advantages, even though we need different types of drones. They don't all do the same things. And I guess when it comes to collaborative combat and everything that people are saying, that there are different drones that do different things, then what we have to ensure is that they can all talk to each other and understand each other, and that the human operators can all talk to all these different drones so they can make better decisions on the mission.
Okay. Merci.
Have we got any questions up there on the screen yet? Have there been any questions chalked up there? Yes, there are. I'll try and decipher them. Let's go down the list of questions. Let's show everybody all of these questions that have been posted. There's one question which has been put. One of the questions pertains to fighting. So how important is it to have a pilot to retain control of a drone? So, how autonomous do we want these drones to be? So I'm paraphrasing a question which has been put by one of our participants here in the audience. So who'd like to take up this one? So if I understand the question, in the naval group, we work with autonomous systems. These are vessels, huge vessels. They could be small submarines or surface-faring vessels, medium-sized, bigger ones as well. And I would just like to specify that they are unmanned. I like the uncrewed. I like the term uncrewed. There's no crew there. I think when we design a boat, we always have that problem of, the man on board, which is the motor behind the design. So now we are designing systems with the same performance but no crew on board. So you've got none of the difficulties of life on board anymore, and you can add further autonomy for these missions. When we talk about decision-making autonomy, there is always a chain of command. So the drone is questioned before the mission, and we set objectives, high-level objectives for the drone. They're very well defined thanks to the supervision autonomy. And the drone, with its embedded autonomy, will suggest to the operator several ways of reaching the target. There are typical types of missions. So the operator receives the information, makes an analysis, and depending on what the operator wants to do, will then define more precise criteria to enhance the performance, to make sure that the autonomous system knows what the goal is. So there's that interchange between the human and the machine during the preparation phase of the mission. And then once that clarification has been made, we enter into the phase for clarifying the doctrine. This is very important, particularly if the device has a weapon on it. So we set a framework with rules that cannot be changed. So there's a zone, duration, actions to carry out. For example, when you're in an underwater drone, you can talk about the maximum submersion. If you say to a drone, you have to go out and detect the presence of a submarine, then if it detects a submarine, then perhaps it will go right up to the submarine. So if we haven't set a limit, it will probably go right up to the submarine, so we can say and stay 300 meters away from it. So the drone takes stock of these orders, and it's not its embedded autonomy which will understand all of that. There's an independent module which is there to ensure that the autonomy of the drone corresponds to the mission, and so that all of the rules are respected. So we've got these two embedded authorities which are very different but very important. Earlier on, we were talking about the fact that the operator needs to monitor the mission. So we talk about a digital twin, the digital twin of the mission. So it's a representation, a very precise representation of how the mission is unfurling. And the operator, once the drone has dived down, the operator follows the drone thanks to a predictive model which follows the twin, and when the drone comes up to the surface, either to take a photo or to send statistics, then the operator takes that information and then can check whether or not the mission is unfurling as planned, or whether the drone has adapted its behavior to an environment. There have been cases when the drone brings the mission to an end, halts it, because according to the rules which we've given the drone, it could not reach its target, fulfill its mission, so it goes back up to the service as if to say, I cannot carry out my mission, I need fresh instructions. This is really important because it enhances the trust criteria between man and machine. And a final point, and then I will hand the floor over to my colleagues here. The digital twin, if it is to be trustworthy, well, it cannot only be based on simulation data. It really is essential to have environmental data, and you can only get that when you're out in the water. So that's why we've got many demonstrators. We carry out a lot of experiments with the Navy because those hours on the water at sea enrich the digital model, and the more reliable the digital twin is, then the greater the trust is between operator and drone. And is there a pilot in the plane, is the question. That's what the public wants to know, and also decision makers, etc. They've been saying in 2040, will there be a pilot in the plane? And the answer can come at different levels. When we take a look at next generation defence in the States, they've got the FCAS program in the UK, Russia, etc. They've all got a component which is in the high intensity zone. So operational issues are converging here. So of course there is a risk of scrambling if you've got a cyber attack, including at satellite level. And here the tactical unit in the mission bubble has to continue to with the mission, and the pilot has to take over some of the commands there, mission management, battle management. So the pilot becomes the commander and will be at the head of the mission. The second element, it's not only as a reaction to scrambling. We see an operational advantage to have decisions taken as low down the hierarchy as possible. Subsidiarity, we delegate control to the pilot cockpit, because that is what is going to give us speed, agility, and the pilot is often the best place to take a decision on the spot without waiting for the statistics to filter all the way up to the central command post. So this chain is created, we need the pilot, and that comes back to the question which we broached earlier on, the ethical notion. With all of this subsidiarity, if a decision needs to be taken, if there is a kinetic impact which is going to have collateral damage, then the human being has to take this responsibility. That takes us back to the doctrine and the rules of engagement. However, it's not the human as we know the human today. It's a human being aided by AI. And we often talk about the pilot with his X-wing, with lots of technical tools. So we've got this AI assistant plus the pilot in the cockpit will create that agility. And it's not like today's aircraft plane. We're talking about an augmented pilot, really, augmented by the support of AI. Yeah, I'd like to add something to this. Yeah, I think Bruno's raised a good question here. If our combat system is founded on kinetics, then it will be difficult to guarantee this in all circumstances. If you lose connectivity, then you'll be swamped. And so it can be complex. AI can understand complexity, but there are some more political, strategic parameters to take into account. And you do need the human being to understand that wider context, to understand whether the program is going as planned or whether the mission needs to be changed to respect the instructions. And that would be too difficult to encapsulate in an algorithm. We really need to have human beings at the forefront. It really is key. as far as doctrine is concerned, doctrines have already evolved way ahead of technology. We've got the American Air Force doctrine has evolved from centralized command and decentralized execution to centralized command, dispersed control, and centralized execution. So that principle is already in the doctrine manuals in the US Air Force.
I think that we need to be confident that the drone is safe and secure and that it will perform as we expect it to perform. But we also know that there could be failures, like people said. So industry, and I know they are working on this, they need to come up with ways to make the systems resilient. But when there is a failure, and there will be failures, it's important that we do have a human operator that can intervene. So I think it's a balance. It's about understanding what AI can and cannot do, and when do we have to take responsibility, to fix things when they go wrong.
C'est une excellente.
Well, that's a great transition into the second part of our discussion. We are going to look deeper into these questions. We've already broached them on many occasions, but let's go deeper into detail about AI in these autonomous systems, in collaborative combat. But not only of these autonomous systems, but all of the other systems that participate in this collaborative warfare. So the first question that comes to mind is, when we look closer in detail, how is it going to work? And if we want to get down to the nitty-gritty, these AI techniques well, how are these AI techniques going to function? What is their job going to be? How are they going to work? And then the second subject, the second aspect, is what kind of challenges are there to them functioning properly? What kind of timeline are we looking at? Is this something simple to solve? What are the bottlenecks preventing it from working properly? And we have these bottlenecks. They can be of all types. They can be technological or regulations. What are the obstacles in terms of standards and laws? And the final point, which we have talked about, and this is the cognitive aspect, the trust. The question of trust in AI, which is absolutely central, and we will wrap up our debate on those points, and then we'll interact with the audience. Who'd like to kick off on either of those, on any of those points? Yeah, as far as AI is concerned, yes, it's involved at several levels in collaborative warfare. When you're preparing a mission, during, and then feedback afterwards, as with the drones, you've got different notions of autonomy, cognitive, navigation, shared autonomy, as with our sensors, with a capacity to carry out recognition, classification, etc. We've already said that collaborative warfare means getting advantage over your enemy. Thanks to your partners, you're doing better than you would if you were on your own. There are challenges in terms of the operator, the stress, of course, because there's a lot more stress in combat, a lot of data to take on board, a lot of suggested values and decisions to be taken. And there is also a need to communicate. You have to be in phase with your ethics committee. You've got these little... you've got this communication, and you have to feedback your decisions. AI is necessary, And it will be part and parcel of our everyday lives very, very soon. In terms of constraints, the main constraint which I see when we're talking about combat systems is sovereignty. How can we make sure, we've seen this today, that many components come from all over the world? They don't come from the state who owns the system. We have to make sure that we can develop sovereign AI. And that begs the question of these big companies, bigger than us. We work with different countries, etc. And we have to duplicate certain elements. And we can pool other generic elements of engineering. And there's another challenge in terms of processing capacity. We have more statistics to crunch, and our calculation capacity is quite close to the drone. That will require AI, frugal AI, that will be able to work very, very quickly with very few resources and crunch a lot of numbers. And the third challenge, which is a human challenge, we've talked a lot about drones. And we know that when you use a drone, you're not going to use the same operators, not the same members of staff, it's not the same instructions. So how do we change all of our human resources, and how can we make sure that all of the staff are trained and adequate? We have different members of staff. We've seen that already. We're not talking about the same people in 10, 20 years' time. They're not going to be the same profiles as we see today. So these are the main challenges as I see them. And we address these through tooling and engineering, which can give us development frameworks. There's also the question of sharing data. We've got cognitive AI, which is well known, and which can give a development framework. These are the main challenges that we have to deal with for this collaborative warfare, for drones, including AI, so that it's very operative, and it works with a high level of trust. Yes, I want to come back on that question of trust and regulations. Well, why don't we talk about that in the final section of our discussion? Let's try and stick with the questions of how it works, what are the challenges, what kind of technical locks have to be opened. And then afterwards, we will talk about trust. We'll divide our session like that. Well, I can say that I'm in agreement with what Lionel has said. At Naval Group, we talking about the first gene of AI. That means a lot of things, of course, lots going on. There are technological cycles. Every 6 months there's an innovation, there's a new type of algorithm, there's a more powerful calculus. I think we have to remain humble, but also coherent with the way in which AI can be deployed so that humans and doctrines can adapt. In 3 to 5 years' time, there will be a first generation of AI that will be based on 4 technical branches. Lionel mentioned them. Data processing, I think we all agree about that. So here we have machine learning. We're starting to implement machine learning algorithms. We're talking about symbolic AI, and also data that is going to be generated by generative AI. Let's not be fearful of that. There's ChatGPT, everybody's talking about that. So how do you implement it? What kind of technologies can you use with that in defense? ChatGPT is not French. We've talked about sovereignty already. So we too have to think about these issues. There's another subject which is key, and that is learning. Reinforcement learning. How we train our algorithms, how can we make sure that our AI algorithms are reliable and high performance and robust. We've talked about cyber resilience, that's a key topic. And there's everything pertaining to operational research in the naval field, but also all questions military. How do we plan? How do we enhance complex planning? Thanks to data, which is not necessarily military data, it could be geopolitical data. How do we use what AI can bring to the table. And there's another subject, and that is the multi-agent system. That's we're talking about the TRL. In terms of defence, it's quite low level, but we must open our eyes to the future. We must look at that, and we can see how we can implement these technologies. And as far as collaborative warfare is concerned, it's very, very important. So we've talked about trust, and from an industrial and technical point of view, we have to be able to kind of get rid of that notion of the black box. AI will provide information to an operator, and the operator cannot have trust if it doesn't understand how the algorithm has thought of the issue through. So if the operator only receives a piece of information and has to believe in that to plan the operation, then if the trust is not there, it's not going to work. So we have to see how we can incorporate AI into the system, and that really does involve factoring in human beings. We've got the final user, and we've also got the integrator and the designer. In the military world, about 20 years ago, we were developing IBOs. These were operational need designers. These were human factors which enabled us to design combat systems. So AI can help with the development of these algorithms with the operators, because these IBOs, as we call them, we would construct them and we would build them with the Navy. So with the sailors, with engineers of naval group or our partners, we would all work together in a collaborative platform, and we would nurture our trust in that way. I think we really do have to get back to this way of working together to design our systems, and we have to sweep aside other ways of doing things. In terms of defense IT, we use the DevOps, which is a way of designing complex software in an iterative manner. And we have to be able to do exactly the same with MLOps, machine learning operations, because we are going to have to implement these technologies. And so this is a change of paradigm in our engineers and our architects' heads and in our software designers. These are not necessarily people who work in defense. We often use people in startups who focus on new technologies. So we, the defense industrialists, we have to take that on board, and we have to adapt our industrial processes so that in the future we will have systems that are more reliable. My final point is, I believe that, yes, AI has to be trained. At Naval Group, we've decided to invest in autonomous system demonstrators, and it really is important. We have to get those AI systems out onto the water, make them sail around, take to the water, and the feedback that we can get will be so important, and post-mission analysis is key. And thanks to all of that data, which we will be recording when these autonomous systems are sailing around, we will be able to create these digital twins and have a almost picture-perfect picture of what's going on in the mission.
I'm very pleased that we're going to talk about AI in detail. There's one thing that annoys me a little, because it's something that rather vague. There's a lot of globish here. There was a lot of technologies are encompassed in this area. These are just modern algorithmic-based technologies. This doesn't mean there aren't other technologies, other algorithms being developed in this area, which can be just as relevant and just as powerful. It's just that some AI technologies provide interesting aspects, because unlike people who have volumes of space, I know you have a lot more than we do, there are three things that we have to count on, which is the volume. We just make very small objects that are very intense. There's not much energy in them because they're difficult to make. Then we have computation possibilities that are very limited on board. So we don't have the same capacities as my colleagues. So we have to make different choices. So integrate AI only when it's necessary. It'll be more effective than a conventional algorithm, less heavy to integrate. We can deep neural networks. And we can train the system by thousands of repetitions, making it very effective and high performance. This makes it a very light system to embed, and this makes it very useful for us. Another limitation is the explainability. Talking about confidence. Confidence is one thing. Then we have the qualification as well. You have technical reputation, which means, okay, we think we can use that weapon, but we can educate the operator and we can make them trust the system and give it confidence. We have to go through a technical authority which has to validate. If we not able to convince the authority of the justification and the phenomenon isn't completely explainable by mathematics, then the authority can reject it. So that's a dialogue we have to have with our customers to say, what is the acceptability for the technical authority, for the operator using a certain technology? Will it be accepted or rejected? This is a dialogue that is underway. We haven't solved this problem. It's quite complicated. We've been talking about frugality. This is an important concept for us because we have a lot of restrictions and we can't embed connectivity technologies all the time. Many times these technologies are not recovered, and once the mission is complete, the capacities have been consumed, and it can't put the same price as we would on a ship or on a vehicle. So we have to think about connectivity, and so we have to comply with a very strong digital frugality. And this means we have complex systems that are very limited, and we know also they will be attacked by the enemy. And so this changes the way we see things because we don't have the same contributions in terms of data. So we have to have a much more frugal approach. This is a different approach for us. I'm pleased that we're going to look at the technical area and enlighten people about this rather generic theme of AI, which people have a lot of funny ideas about. It's just an algorithmic-based technology, which provide much better performance than conventional algorithms. It's just a different type of algorithm. Following on from what you were saying, concerning what you were saying about data, we know that one of the essential differences between military missions, the application of AI techniques for machine learning, for deep learning, and military applications, one of the main differences in criteria compared to the commercial world we're familiar with is the number of instances in the use cases. You can have high-performance AI because there are billions of uses that have been recorded. If we look at the example of anti-submarine combat, what do we base work on? Do you think this is a barrier that is impossible to overcome? Could you go into a little more detail? Do you think is it a question of how we approach this in the next few years? We still have a bit of time, but although it is very difficult. To be brief, we have a challenge where a ChatGPT algorithm, which is available to the general public and billions of users, can each time improve the quality of the picture of their dog. And we have use cases which are very much the general public. In our case, these are real missions which are executed very infrequently, where the learning of the mission after the operation is very important, and we make considerable use of simulation to be able to simulate operational scenarios by using the real data blocks that have been recovered from the main missions. And the second point, as was mentioned earlier, is that it has to go through the demonstration phase. For the drones in the airborne systems, we deploy them in test areas where we deploy either real targets or inflatable targets have to be identified. And using these scenarios, we're able to train the drones, and then we do an assessment afterwards, and we improve the algorithms. We launch them again, and in demonstration, the most important thing is simulation, to be able to extrapolate data, which are often rather limited from a real mission, to be able to feed the algorithms, and so we have iterations of several thousand cycles. So it's a mixture of simulation, demonstration, and recovering the small amount of data we have from real missions. And here again, there is a need for the different forces to work in collaboration. and cooperation between the different forces and between the different countries as well, to share the feedback from missions in Syria or elsewhere between allies. This makes it possible for them to improve their joint level of competence. Just to add something, even if we only use simulation, there's an issue to do with data. You're absolutely right. We have to have data with a good level of fidelity. The trouble is that in the private sector, there's a corporate aspect. We are all cooperating with the AI industry, but our enemy is not involved in the cooperation, so it doesn't want to be detected or recorded or characterized or simulated. So our difficulty is there. It's a collective difficulty. We have to be able to bring together as much data as possible so that we can have the best possible learning databases. We can use neural networks. Then we often realize that our simulation has too many unknowns because we are too dependent on data which is not complete and where we have to make too many assumptions, and therefore there are too many risks. I absolutely agree. When you talk about machine learning, the problem is the amount of data based on real experience. It's an experienced soldier who is likely to live the longest. Often this data is classified depending on the country. It's not always shared. Sometimes you can share it, not always. So there's a real issue is that how we train these intelligent systems. If we train at a certain point of time, we come up against the problem of exportability. We can't always export an object to another country if it has been trained using classified data. So we have a panel of data that can train the system up to a certain level. Then we deliver it with a certain level of maturity that has to be improved to the customer with the customer's data. That is a real issue already. We have some solutions, which I'd like to mention, which when we talk about sonar, for example, it's easier in the case of mine warfare sonar because we're processing images. We have tools that we can provide to customers which are image generation tools. We are going to generate images as if they were sonar images so that they can then be injected into the intelligent system so that it can learn. We have to be careful to make sure we avoid loops. So we'd have but there are solutions that exist up to a certain level. I absolutely agree with everything you've said. We come back to the data set. Some very important things have been said. I'd like to come back to what you said, Loïc, about the issue of how we qualify these systems. And that is a real challenge with our navies and with our arms ministry. We've talked about the word certification. We don't want to talk about certifying different types of system, otherwise we'll never be able to achieve that level. And the systems will cost a lot of money. And as we said, these are systems which, although they have a certain value, they will always be exposed more than high value units, so they potentially can be lost. So we have to separate the system and divide it up into different systems to qualify the elements that are absolutely essential so that we can achieve a level of performance that the important thing is for it to remain within the framework. What we want to make sure is that when the system isn't certain, it stops, or when it comes out of the framework, it also stops. So there's a real whole set of requirements that have to be defined. I think we all four of us agree on that with the DEA, the French Ministry of Armies. This is a real challenge for us, but we don't have much time because these autonomous combat systems, we haven't used one term from the very beginning, which I think is important. We're talking about SALIA and not SALA. These are lethal systems integrating artificial intelligence. They're not robots that are going to act without any control. So we're talking about that particular framework that Airbus and Naval Group and Thales. These are lethal systems. They have weapons or systems that make use of weapons. but they have a certain autonomy. But they're not completely autonomous, and we have to define these technical references that will enable us to accept a number of requirements and to carry out a qualification process. To be honest, it hasn't yet been done, but if it takes us 10 years to do it, they will never be included in our armed forces, and I agree, they also won't be exportable. To continue in the same direction, the second element of our theme is about the question of this regulatory normative framework. Could you say a few more words about this, perhaps, each one of you? About what is missing, or maybe there's too much regulation to make sure this framework is appropriate. For example, I'm thinking of the existence of a data policy. How do you see the situation in this area to make sure this is a facilitator rather than a barrier to improve the maturity of these systems?
About data access, if I can. I think militaries and government bodies and the defense industry need to come up with new ways of working. And we know it's possible because we know that that's what's happening in the Ukraine. The defense industry is having access to information so they can then go and train their algorithms and AI models so they can really respond quickly to the situation on the ground. So it's trying to think about what can we do better. So in terms of regulation, we know that there have been initiatives, and they've come from governments, international and intergovernmental organizations, and the private sector and civil society. But they are very much looking at codes of conduct and guidelines on how to develop responsible AI, which it's focused just on considering what the effects might be for society. But I think, the EU Act is going to be the first regulation. So at the international level, the worry is that, AI may develop, faster than we can regulate it, and that we may not be able to prevent, harmful effects from artificial intelligence generally. If we don't regulate if we don't come up with what standards do we want, the design to have, so that will have an impact, obviously, on safety, security, trust, and everything else that's got to do with AI that could make it, a challenge for everyone to use it, really.
On this subject, in the context of regulation concerning applicability of AI in defense, what's missing is a framework of standards and rules that we can rely on, because we, as a development and engineering companies, we work on the basis of a requirement with specifications that we have to meet. If you're talking about ethics linked to AI, we don't yet have the clearly defined set of requirements, although we have ambitions to work on the explainability of AI, to be able to reconstitute the different stages that have led the algorithm to reason in a particular way. The framework is missing. The problem is that this framework is very difficult to develop on a national level. We need to have an international framework. So therefore, we make use of the qualification criteria, the doctrine, the rules of engagement. These are frameworks that do exist, but in terms of regulations, there's a bit of a vacuum at the level of the United Nations. There have been attempts to regulate the use of the least autonomous weapon systems, which have not been successful because we have countries that don't have the same interests or the same cultures, with political systems that are sometimes democratic but sometimes not, and don't have the same limitations. So this framework is taking a long time to develop on an international level. So we are faced with the same challenge. We are seeing a debate today about the applications of AI in the civilian field. The speed of development of this technology is difficult to control. And we find it difficult to set up the regulations quickly enough to be able to control this development. The speed of development of AI for applications already applicable in the defense sphere without having a regulatory framework that exists. So I think we're going to work on the basis of cycles, as you mentioned earlier. We're going to have to push our discussions and by making proposals, by asking questions about how we qualify them and validate them and approve them. And by working on the basis of these cycles, we will be able to define a certain framework. The problem is, what will be the motivation of each country to commit to a certain level while looking at what the neighbors are doing? And so this requires international cooperation in the FACS. We have worked on this in Germany on the responsible use of AI. We succeeded in establishing a Franco-German-Spanish dialogue in this part of this program in order to have a context of rules. It's a difficult subject. We're moving forward slowly, little by little. I agree with what you say. Let me look at things as if the glass was half full, because in France we need to make progress, and it's true, but things are happening. I'd like to mention a few actions. First of all, the report of the Defense Ethical Committee of the 21st of April 2021. We've all read it. If you haven't, I encourage you to do so. It's online. It has the merit of defining a certain framework and making recommendations which are very meaningful and which draw a link between the operator, the soldier, and the engineer. It does exist. It defines the SALIA concept I mentioned earlier and defines interesting guidelines in order to be able to develop these systems. The second type of action is the AI Act, which is the regulatory European regulatory effort. We know that the European legislation takes a long time to become a reality, but it has begun. They are starting to define a certain number of requirements at the level of the systems concerning risks management, the robustness of cybersecurity and human control, the transparency of information, the way that technical documentation will be generated, also the notion of data governance. These are important principles. The important thing is to implement them. It's not for the defense specifically, but we can be inspired by that. I think we have to use this as a basis for what we're doing in the defense area. Then we have the AI Trust initiative, which is to ensure we have an AI that we can trust. In France, we have the French equivalent of Confiance AI, IA. I think we're all members of the consortium, Naval Group. We are. I think MDBA. I think we're all involved in that. TELUS is involved in this AI Trust initiative in France, and the aim really is to create an environment where we have tools that can be integrated into networks so that they can be implemented in AI. This is for. So far, this kind of work has concerned civilian areas such as automobiles, but I think we can use this as a basis for our work, and we need to listen and observe what is happening. And for us, as in the French defense industry, we need to be able to structure this engineering work, taking into account the public procurement code as well. In other words, how do we change the public procurement legislation in France so that we're able to implement a weapons program with AI, going through all of the different phases from the statement of requirements right up to qualification. Concerning the standards that are being developed, all of the work in AI, there's a lot of business intelligence that is required, a lot of practices that are expressed that can be used without them becoming normative. Let's be careful not to only focus on AI. There are other issues of interoperability that are very important, I think. Interoperability concerning connectivity, for example, because at the moment The system that is being developed is bubbles of interoperability in Europe, which is not interoperable. We need to make sure that people are able to talk to each other. And that's an important subject. And the other subject concerns the interoperability of data policies or data formats. If we're generating rich databases which enables everybody to learn more quickly and for the systems to be able to have interesting data to learn, we have to agree on the data format standards, and we have to remove a certain number of national restrictions where at the moment the countries don't want to share their sensitive data even between allies. So this is a barrier. Were you talking about the barriers? I think interoperability of connectivity is one of those, and interoperability of data format is another. And we have to have a more open policy, more open data policy, enable to improve this data sharing beyond the national framework, or as part of an industrial project where the framework will be clearly defined. I'd like to react. I think it's important to look at the work that is being done. I'm thinking of the work being done by NATO in the maritime level on drones, the Maintainment Initiative, which brings together 20 countries, which is working on two pillars. First of all, the concepts, to develop a number of concepts which are acceptable concerning drones and the collaborative warfare. We've talked about interoperability. The idea is to go as far as interchangeability. In other words, I have a drone that I can loan to Italy, for example, that there's a notion of handover here. We can go quite a long way in that area. Then the second pillar is the experimentation pillar. Every year in Portugal, we participated last month in this initiative. It's important to participate to see how things are changing and how ideas are emerging about standardization concerning the systems, concerning C2, and the exchanges between drones, and about the exchange of data with about 20 countries who are working together and thinking together about how we're going to eventually get to a solution using the push-pull activities, first of all, so that we have a framework that is usable in operational terms. Now we have some questions, which I'm going to look at. A lot of questions about the exportability of these systems. Loïc, could you broaden your point of view about this exportability of the systems based on the use of SALIA? Is it a barrier? Is it a problem? How do you see things? This is the first use cases that will make this clear. In France, we have a body which is completely independent in this area. It gives an authorization which defines what can be exported or not. And this is the body that will decide whether this will occur or not. You have agents and software that have been trained with sensitive national data, and there will be restrictions. As you were saying earlier, the problem is that when you use more generic data, what sort of level of performance are you going to be able to provide and guarantee? So for export systems, if there are limits imposed by governments, you have to have systems that are going to use different types of data. I absolutely agree. But we're really only at the very beginning of this process. We are being confronted by this question. It's a piece of work that we've begun with the DGA, with the French Arms Ministry. And we're working on this in a working group, but it's not simple. The question of clearly defining the architecture of the systems and what can be embedded in the architecture. Apart from data, there's also the problem of local content or the technology transfer. Often the local customer says that they want to develop something locally using a local company. To develop the autonomy, then you have the question that is being raised of what can be developed locally. We have to think about an architecture that is modular as possible, with levels of transfer that are acceptable. This can be a simple configuration or the modification of the man-machine interface, and then a whole black box technology which can be not transferable and which cannot be violated either. And there's a question of the training to improve performance. As Loic said, this is absolutely key. Today, already, it's complicated with our own Ministry of the Armies to train our systems with data that is classified. You have to declassify the data to be able to have access to it and then to be able to use it for simulations and train the algorithms. So when we're going to, perhaps tomorrow, if we want to export these AI systems, which has part of its background behind it, it's a real problem. I don't think we have the answer at the moment, but it's something we're going to have to deal with in the future. We're right in the middle of it now, and we don't have much time to find the answers because other countries who don't have the same ethical problems, I won't mention them, but I think you can imagine who I'm talking about, they are starting to export already. They are exporting autonomous systems, they're exporting AI systems, and if they replace us, then it's going to be difficult for the French defense industry to have a strong position in terms of its export. Would you like to add something?
In terms of the data, I think there's obviously a very big tension on here because we want to develop AI capabilities and we need data access to be able to develop them. But then again, how do we tie this with the fact that we are liberal democracies and we value privacy? So this is something that citizens expect, right? So there's a political issue that I think we need to find out. We don't really know yet how to solve it. And yes, we need to be able to have capabilities that are better than those of our opponents. But how do we work to have those capabilities without compromising on our values? I don't have an answer. I don't think anyone has an answer at the moment. So, yeah, it's something that we have to consider as societies. I think that's what I would say on data.
Quelqu'un veut, Monsieur Collot?
Mr. Collot, just to add on this subject, is a real challenge. We develop safety systems based on facial recognition. These are security systems. In some markets, we can't be competitive because we are talking about countries that you mentioned without mentioning them, who have no trouble about taking photos of people without asking their permission in airports and have a database of several hundreds of thousands of people who are in their system, whereas we need to systematically ask each individual for their permission to be able to use their photo, to be able to enter it in the system, to have this facial recognition. So we have a lot of restrictions and a lot of difficulties because of these requirements imposed by democracies. So I don't think we have much more time. I don't we have time for 2 or 3 more questions to give us a conclusion. In order to broaden our discussion, because the term has come up several times in different forms, which is to say, okay, we're moving in that direction with this technology, which provides us with this this extra value on an operational level, but in the end analysis, if we look at what we've learned from the conflict in Ukraine, because of the mass of information that is available, doesn't this call into question some of the assumptions we made about extra value and about the justifications for investment compared to more rustic and simpler armies? Maybe we could use this as a conclusion to some of our questions.
Alors juste rapidement.
Well, in a nutshell, because we must respect the time frame, I would say that the lessons that we've learned from Ukraine confirm the need to have drone systems that range from the rustic to the very sophisticated. Drones have contributed greatly to air combat. It brings mass at a low cost in a system where it is increasingly difficult to find fighter pilots. We can have huge fleets of drones, whereas we can't have huge fleets of fighter pilots. So we have to be able to combine the fighter planes with these drones, simple drones, complex drones, which will make up for the mass at a low cost. So this confirms the equation that we are looking for in our FCAS, the Future Combat Air System. And we have to have an operational unit to work between industrialists and the rest to work on this threat, taking into account lessons that will be learned in the Ukraine, but also the conflicts in the Middle East and elsewhere. If you were here for the round table this morning, we use the term differentiation, and I think that applies here as well. Differentiation in terms of your force, your weapons, because you need very intelligent, high-performance weapons at the very beginning, and then when you get into the day-to-day army war, then it changes slightly. I think to bring down the price, you have to review your specs, see what constraints you're imposing. And so it's a collective job, it's a team effort that is required there. Yeah, from the Navy point of view, given what's going on in Ukraine, we see that there really is a problem with banning people from getting into zones. When we're talking about under the water, we don't know what's going on, and we realize that how important these autonomous systems are, and whether they are sufficiently intelligent to go into a zone, explore there, stay on the spot, depending what the autonomy is, because we can no longer go there. We realize there are many vessels that can or can't go into a zone, and then there's this second system really does exist. So it really means that we are recognizing the fact that our navies are exposed to these systems. So taking these systems into account means that we have to think about how we can combat these systems. Does the equipment on our submarines and our boats suffice in terms of connecting these other vessels? Look at the Russian Navy, for example. Imagine you've got a paddle with 40 kilos of TNT. You can have the best system of detection in the world, but you will not see it. If there are waves, if there's some swell undersea, you will not see it. So these new threats are very real, and we have to think about how we can reinforce our navies with these autonomous systems that can interact or destroy such threats. So the anti-drone combat, we haven't really talked about that, but that is yet another subject. Oh, a bit of an announcement here. So if anyone wants to join the FMES, now is the time, apparently. You'll go home with a strategic atlas. Whoops. The announcement has not yet finished. There is more in store. She's only got 7 pages left on her speech to read. There we go. So now we'll hear that same announcement perhaps in English. Oh, there go the bells. No. Oops, no. She's just found another page under the desk. It must have slipped off her desk. So in a naval context, what's going on in Ukraine have taught us that we need to be flexible. We've talked about mass, we've talked about drones. We need all kinds of drones, and drones can provide that range. In the Ukraine, there's a lot of DIY drones. They seem to be working very well. And they need flexibility in how you use your communications. You've got Starlink, for example. And on the other hand, we need sovereignty. Because the day when Starlink says, well, I'm going to switch my systems off, I'm not going to let them be used anymore, then everything comes to a halt. So you need great flexibility at every level, and you need a whole range of building blocks and a range of drones.
That we have seen the benefits of drones in Ukraine. There have been so many different systems doing so many different things. They've allowed for a attacks on the sea. They've allowed Ukraine to penetrate, Russians' airspace, almost 500 kilometers away from Ukraine's borders. And yes, it's true that, we had a huge world war in Europe, and that was happening as well. But we were putting people's lives at risks. And now, if that was the case, perhaps, Ukraine wouldn't be trying to hit Russia at home. But the other thing also that I would like to highlight is that there are several different missions for drones, right? They can do surveillance, they can launch missiles, but Ukraine is also using unmanned ground drones for evacuation purposes. They're also saving, the lives of people in the field. So I think that's something good that we have to keep in mind. It's not just fighting.
Merci.
Thank you very much, everybody. Thank you to our panel members. You can give them a nice round of applause. And if we have any journalists here, there's an extension to our round table with our panelists. We've got 15 minutes for the journalists here. So if you want to stay in the room if you're a journalist.
Est-ce que c'est possible de faire une photo devant le... Oui, oui,
combat numérique